going to start off by giving introductory, little introduction to where I'm coming from, what's Sandia, talk about the Vanguard program overall and what we're trying to do to mature new technologies like NextSilicon. Talk about the collaboration and the announcement that Kelly mentioned. Give some details, highlights from that, and talk about a couple projects that are related, a couple other things we're doing in Vanguard. Not necessarily NextSilicon specific, but possibly applicable. Then close with some takeaways. Okay, so I'm coming from the Sandia Center for Computing Research. Picture of our main building is here that I took during COVID when no one was around, so it was a great chance to get a good picture of the building, but I didn't have the keys for the van, so the van didn't stick there. So anyway, so we are kind of charged with interacting with the outside world. We're kind of externally facing, and we try to bring things into the lab. So we partner with industry partners like NextSilicon and the other national labs and academia to kind of try to push the edge of computing. So more specifically, right, we're seeking to push HPC architectures forward. We kind of, I kind of think of it like we've got kind of three main areas. We conduct kind of fundamental computer architecture and software research. We have teams that engage with our application teams, code teams, try to do deep performance analysis and help them improve and make their codes more efficient. And we deploy real systems, right? This is where the rubber meets the road. This is where we expose it to our actual users. We get feedback, and then we incorporate it into this whole site stuff. So, ultimately, we're trying to push forward national security, computing, our modeling and simulation mission. We're trying to push that forward through improving computing. So, within the NNSA, the ESC program, we kind of have three swim lane types of systems we deploy. One are the advanced technology systems. These are the leadership class systems. These are where we do like hero class runs, hero simulations. We have our commodity technology systems. These are where we run the bulk of our computation. These are kind of the workhorses. And then this new swim lane we have is the Advanced Architecture Prototype System program. This is where Vanguard falls into. This is where things like our partnership with NextSilicon fall into. And we try to focus on technologies, focus on developing them, focus on deploying them so that they can get exposed to users and get mature. So that ultimately we can deploy them in perhaps these other two swim lanes. Okay, so Vanguard program overview, just a little more on that, where it fits in here. So starting on the left, we have test beds that we feel that we strive for like a breadth of different architectures. We try to go as wide as we can, deploy small scale clusters, and the users who get on these systems expect things not to work well. They're things are broken, and they're okay with that. They just want to get exposure to new technologies. On the other side are the ATS and CTS systems I talked about, the production side, and then this new kind of mode we have, Vanguard, where we, again, focus on specific technologies. They're larger scale, they're kind of concentrated efforts, and they're big enough to kind of have a center of gravity that's big enough to attract users to them. So really, we want to get users on the systems. Again, they're okay with things not fully working, but over time, over the lifetime of the platform, right, the goal is to mature the technology and get it ready for use, prove its viability. This is a picture of the first Vanguard system we deployed, Astra, in the 2018 timeframe. Our goal with this platform was to show that the ARM architecture was viable for running our challenging simulation workloads. So this is a small part of the team that did it. I'm standing there. And this is a picture of the machine. And ultimately with Vanguard 2, Vanguard 3, and Vanguard 4, we just want to stand up systems like this and show that they were successful, much like Astra was. It's the first petascale ARM platform. First ARM system on the top 500 list as well. Okay, so the other aspect of Vanguard, software is important when we're fielding new technologies that aren't like systems we've had before. Rather than have all the code teams go out and have to figure out the different third-party libraries, the compiler issues, things like that on their own, we have a concentrated effort in Vanguard to field a software stack. So we created what we're calling ATSI, the Advanced Trilab Software Environment, that provides the team creates this integrated software environment, uses some of our applications as exemplars to prove it out, and get it ready so that users have a more or less kind of turnkey software environment that's ready to go, so they don't have to fumble around. So this includes like base level compilers, MPI stacks, I/O libraries, system management is included. So it's kind of the full spectrum of things that you need to get on and then build things like Trilinos and build some of our applications. So we're continuing this forward, and our intent is to develop ATSI for NextSilicon so that we provide this kind of streamlined user experience. Let's see. It's a modular stack. It's designed to integrate with vendor software. So with Astra, right, we integrated with proprietary ARM compilers and some other math libraries that were available. So with NextSilicon, right, we will integrate with the compilers they provide, integrate with MPI, integrate with their math libraries, things like that. We want to integrate these in, have that vendor value add into this common baseline software stack. Okay, now finally the announcement that just came out. There's a QR code there that you can scan that should take you to the release. I'm going to kind of highlight some things in the release, so maybe you don't have to read it, but you should read it for detail. So we've been, we're announcing our partnership with NextSilicon and Penguin Solutions to deploy the next Vanguard 2 platform, the next advanced architecture prototype system. The system integrator for the platform is Penguin Solutions. We've worked with Penguin within the NNSA for a decade plus. They're a great partner for deploying new technologies. And then the technology provider that we're focusing on is NextSilicon to prove out their runtime computable technology. So some of the details from the release, a lot of the actual specifics are still under NDA, right? So I can't share too many details. I'll let NextSilicon share most of those. But what we're announcing, right, is this partnership with Penguin and NextSilicon. The name of the system is going to be Spectra. The logo for Spectra is in the upper right. I think this is the first time we've ever shown this publicly. So there it is. That's our logo. It's going to use the Open Compute Platform format, which we've used in the past on CTS systems. So it's a nice extensible architecture that we can, plug different node types into. So there's a lot of appeal with that, where we could maybe have the same infrastructure we carry forward on multiple systems. And it's going to have chill-dyne liquid cooling, which is it has negative water pressure, so if there's a leak, water flows in rather than out. So that has a nice feature. And they're also, good to partner with on early platforms because they're willing to change their cooling system, work with new boards, make cooling plates, things like that. So that's kind of the hardware level infrastructure. We're expecting to get early NextSilicon hardware in the second half of 24 that we can start developing with. Right, we're currently using the simulator platform and some early hardware, but the target hardware we're expected to get in 24, followed very closely by the Vanguard 2 platform itself, with acceptance planned for our fiscal year 25. So this is a Trilab project within the NNSA, so we're working together with Los Alamos and Lawrence Livermore on Vanguard. And so our goal, right, is to show that NextSilicon hardware, the runtime computables, reconfigurable hardware with real-time adaptive optimization based on telemetry, that we can use that on our actual simulation workloads and get good performance. And in particular, we're interested in getting good performance on things that have been challenging to accelerate with GPUs, right? We think there's potential. This could help us a lot with those types of workloads. Another appealing aspect of NextSilicon is their focus on HPC, and they're focused on enabling applications to run out of the box. Sorry. To run out of the box without modification. So, we can build our apps and have them running immediately, and then over time we can adapt and optimize. So that means things like our Cocos middleware layer are currently running on NextSilicon, and additionally we're working to create an optimized back-end version of Cocos. And Cocos is kind of a key library that is the key abstraction layer that most of our workloads sit on top of. So once we have Cocos ported, that gets us a long ways to being able to run full applications. A few quotes from the press release, right, that kind of get to the heart of some of the things I just said. So from Elad Raz, founder of NextSilicon, right, using intelligent algorithms to identify and accelerate the critical path performance, right? So a key insight is, applications are often repetitive and they have a critical path. So if we can detect that and optimize it, we can, optimize both performance and power. And then from Kelly Markart, who just spoke, right? This collaboration with Vanguard has been a key enabler with NextSilicon to bring their technology to market faster and with higher quality than you could have done on your own. And this is really what we're after with Vanguard, right? We want the relationship to be mutually beneficial. We want to help vendors develop and mature their technology, and in return, we push computing forward and get new hardware, new technology providers, new technologies that we can deploy in our production systems. And then lastly, from Jim Laros, the lead of the Vanguard program, NextSilicon's focus on HPC is an important part of why we chose the technology, right? There's a whole bunch of different ML startups out there that are focusing on ML hardware. The fact that NextSilicon's focused on HPC is a very appealing aspect to this, because while we do ML, we centered on HPC at this point. Okay, so that is the release that we just put out for SC. Just want to briefly mention a couple projects we're also kind of doing under the Vanguard umbrella, related to Vanguard. So memory is a key bottleneck for us, the memory subsystem. So NNSA is investing in a program to try to improve our application performance by 40x by improving the memory subsystem. So we've announced several contracts with Cerebras, Sandia, and Intel. They are all focused on improving various aspects of their memory subsystem, and ideally these technologies will be broadly applicable to multiple technologies. And this is another example of how we have multiple partnerships with vendors to improve their products. And then lastly, we've been looking at RISC-V and trying to enable RISC-V in the HPC space. We've had a project for a couple of years, and we're using some of the open source RISC-V hardware that's out there, some of the design tools that are available, combining that with the ASCII stack I mentioned earlier, and some of our workloads to create hypothetical RISC-V SoCs that we can deploy with FPGA accelerated simulation, run complete HPC software stacks on, and start to try to mature the RISC-V software stack. So, as a system software researcher and operating system person, it's pretty cool that we can do this, boot it, get maybe 1/50th real time, and be able to change both the applications, operating system, and hardware itself. So that's a fun new capability. Okay, so to conclude, some takeaways, right? We're announcing, I covered the Vanguard program where we're seeking to have focused activities to mature promising new technologies like NextSilicon. We're announcing the Vanguard 2 platform, the partnership between Penguin Solutions and NextSilicon to deliver Spectrum, which we expect in next year to start rolling in. So we're excited by that. And we're excited with the potential of leveraging reconfigurable hardware, leveraging the advanced software stack and advanced algorithms to identify the critical path and try to optimize that as applications are running. So we need to show that's viable for complex applications. And just as to conclude, right, this is what we do. This is what's fun. This is what's fun about working in national labs, engaging with vendors like NextSilicon, maturing their technology, pushing things forward, and trying to make sure our future HPC needs are met. So with that,